So let's talk about International Standard Units. These are called SI units. And the reason why it's abbreviated that way is because it's abbreviated from the French word. And I'm not going to attempt to read that. Oh, maybe I will because it's funny. Système International des Units. Wow, I do not know French, but it does come from abbreviating those the French word for international standard. So when we look at the international standards, and this is across the world, and in the U.S. too, because in science we use the metric system. So for length, we use meters. For volume, this is a derived unit or a unit that's calculated from one of the standard units. And so we take height times length times width. And if you look at the standard unit of meters, that would be meters times meters times meters. So that would be cubic meters. That would be about the size of a dishwasher, so if you can imagine that. And that's a little bit too big, or I should say it is too big to use in chemistry. So we don't use cubic meters in chemistry. Instead, we use, see if I can advance it here. We use cubic centimeters. So if you were to take 1 centimeter in length and then length times width times height, you would get 1 cubic centimeter, and that is equal to 1 milliliter. So these are interchangeable. So if you see cubic centimeters, don't freak out because it's a cubic unit. Just know that is equal to 1 milliliter. And we'll use that a lot in the lab. Our lab equipment is listed in, or is measured in milliliters. So how many milliliters are in 1 liter? Well, if you know your metric system, you know that milli means 1,000. So there's 1,000 milliliters in 1 liter. If you were to look at 1 liter, a 1 liter cube, you would measure 10 centimeters on each side, or 1 decimeter on each side. So 1 decimeter times 1 decimeter times 1 decimeter, that would be cubic decimeters. That is also equal to 1,000 cubic centimeters. And you know that 1 cubic centimeter equals 1 milliliter. So we get right here at the bottom down here. What should you write in your notes? What's in the boxes? You should know that. So know that 1,000 cubic centimeters does equal that 1 liter. Occasionally in chemistry you do see cubic decimeter, but in my class most of the time you'll just see liters. International unit for time is the second, and if you want to go in the extra videos you can see Michael Phelps win a gold medal by a centisecond, which is 0.01 seconds. He won a gold medal. Temperature, the standard temperature unit is Kelvin. And you might say, hey, I thought it was Celsius. Don't countries in other parts of the world measure the temperature outside in degrees Celsius? The answer is that is correct. In chemistry, we want to avoid having negative numbers, especially if we're using a formula, and so we use the Kelvin, and there's a little conversion right here, so memorize it now. You're going to use it throughout the year. And how you measure Kelvin is you just add the number 273 to the degrees Celsius. So in the chemistry lab we'll measure things in degrees Celsius and then just do this calculation to measure in Kelvin. And notice that you say degrees Celsius, but for Kelvin you just say Kelvin. So if I was at 0 degrees Celsius, let's go ahead and do that calculation. So if I was at the freezing point of water, so 0 degrees Celsius, how many Kelvin would I have? It would be 273 K, or Kelvin. So I would say 273 Kelvin is equal to 0 degrees Celsius. International unit for mass is the kilogram, and so this is a little bit different. So if you watch that little extra video with the 1970s commercial, they said a gram is about the weight of a paperclip, and so that's a little bit too small for just everything. So if you're to measure the mass of like a human, that would be a lot of paper clips worth. So instead of using grams for this international standard, they use kilograms. So that's just something a little bit different, that unexpected, but know that kilograms is the standard. And what we do is we use a balance. So in the classroom we use a balance that's somewhat like this. Okay, and when we're talking about a balance, we're comparing it to something else. So inside our electronic box here, there's a weight comparison. So we compare a weight here compared to an object here. So we can compare one to the other and determine what the mass is, or the quantity of matter. So somewhere in France, I think there is a kilogram right here that is used to compare to other measurements across the world. And I think that they might have changed this so that they're actually comparing it to something else. But this is the international kilogram. And notice it's under two layers of glass just to protect it. Mass is used in chemistry. Most of the time we are used to weight. Weight is the measurement of the force of gravity on an object, and weight is kind of shied away from in chemistry and other sciences because the weight can vary depending on where you are around the globe. The closer you are to the center of the earth, then the more you will weigh. Again, because of the force of gravity. And you use a spring scale to measure weight. So that spring will go down and tell you how many newtons that it is. That would be the international standard unit for weight. And if you're wondering, well, what's a newton compared to like a pound? There are about 4 newtons per 1 pound. So if you were a person weighing about 100 pounds, that's about 400 newtons. And so again, because of gravity's variations, we tend to stay away from weight. You might be familiar with a spring scale at the grocery store. This is measuring weight. So the spring goes down and it tells you the weight of your apples. NASA has actually gotten in trouble using newtons versus mass, or in grams or kilograms. In 1999, NASA sent a satellite to Mars to observe the climate of Mars, and it had to enter the atmosphere to get into orbit around around Mars. And it cost $125 million to do this whole project. And the force of the thrusters needed to slow it down as it came into the planet, it was calculated in pounds, but the software, because this was an international project, the software thought that that value was in newtons, and so you know that newtons are a much smaller unit than pounds, and so the thrusters just didn't kick in enough thrust to prevent it from burning up into the atmosphere. So that was a very expensive meteor. So $125 million burned up in the atmosphere. Another derived unit that we see in the international standard is density, and density is measured by measuring the mass and divided by the volume. So here's your formula. Density is mass over volume. So I remember it by saying mountains over valleys, but a lot of people like to draw this little heart saying that density equals the M, the top part of the heart, divided by the V, the bottom part of the heart. But you need to know how to do calculations in density. Now when you look at the density formula, you can manipulate it to help you solve for what you need to solve for. So if you're calculating the density, you can measure the mass and divide it by the volume. But let's say you know the density, but you do not know the mass. So you know the density and the volume, but you don't know the mass. So what you would do is you multiply each side by volume. Volume would cancel here, and I would get mass is equal to density times volume. So then I could go ahead and plug in my known values for density and volume, excuse me, to solve for mass. Well, let's go ahead and solve for volume. What if volume is not known, but we do know density and we do know mass? So again, we're going to start with density is mass over volume, mountains over valleys, okay? And I would cross multiply, so I would get density times volume equals the mass. And then I would divide each side by density. So density would cancel, and I would be left with volume is equal to mass over density. So we have some formulas here that we can use to help us, and of course the original mass over volume. If you feel uncomfortable manipulating the equation, you can just plug into the density equals mass over volume and then just follow normal algebra rules to solve for the unknown. So in chemistry we use formulas a lot, so you'll be given every value except the one and then have to solve for that one unknown. But this is a way to manipulate your formula. Density is really important in chemistry because every substance has its own unique density. And it doesn't matter if you have a small piece or a big piece, the density will still be the same because it is a ratio. Let's look at the density of gold. So gold is a really heavy metal, and it has 19.4 grams per cubic centimeters or grams per milliliter. Usually if we have a solid, we use cubic centimeters. If we have a liquid, we use milliliters, but we can use cubic centimeters for everything. So how do you measure density if you have a cube type shape? And how do you measure density if you have an irregular shape? So if you really look at the formula, you have mass over volume. And to measure the mass, you just put it on a balance. Okay? You put that on the balance, but the volume, it depends on if you have a cube shape or an irregular shape. Now, if it's a cube shape, you can just do length times width times height. So you can just measure the three sides of a cube. That will give you your volume. Okay, and then you can just do the calculations. If you have an irregular shape, you're going to use something called Archimedes' principle. So the story goes, and I think it's more of a legend, there was a very wise man named Archimedes, and there was a king of his country, and the king wanted a new crown commissioned and gave the gold to the goldsmith to make him a crown. And when the king got the crown, he was suspicious that not all the gold that he gave to the goldsmith was used in his crown. And so he wanted Archimedes to figure out if his crown was pure gold or if there was some other metal that was mixed in with it, because then the goldsmith took some of the gold for himself. And the problem was is this crown, and I don't know if I could do it justice, but it had all this gold leafing. So it was a very irregular shape. It had all this different detail on it. And so Archimedes didn't know how to do that because he couldn't do length times width times height because it was just too ornate. So he was taking a bath one day and he noticed when he got into the bathtub that the water level rose. And he said, wow, when I get in, my body volume displaces the water. And so this is known as the Archimedes principle or water displacement in order to find the volume. So what you do is you take a container, so this is a graduated cylinder for example, and you measure the water level before, and then you put in your little object in the bottom, your little irregular object, and then you measure how high it goes, so that would be your after, and then this is the volume of your irregular object, and so then you'd put that into your formula. But this is Archimedes' principle. So either length times width times height if you have a perfect cube, or Archimedes' principle works by measuring the volume of water before, you put in the object, and then after. So and then subtracting those two values. Density determines if an object will sink or float, and it's very convenient that the density of water is 1 gram per cubic centimeter or 1 gram per milliliter. So anything that has a density less than water will float, anything that has a density greater than water will sink. So what kind of things float in water? Well, ice floats. Ice is just frozen water, and because of the crystal lattice formed with the ice, it ends up being less dense than water and it floats. Very, very unique, because most things have greater density when they're in their solid form. Wood floats, so you can see the density of wood. Styrofoam floats. Here is a list of densities of a whole bunch of metals, and you can see most of the metals will sink, which is what we expect, but there's actually some metals here that float. Can you find them? So lithium, sodium, potassium, those are the ones that float. You can see that their densities are less than water. And here's potassium right here. I'll underline it so you can see it. So kind of interesting that some metals are less dense than water. Let's go and do some calculations in density. So we have a student measures the mass of a liquid to be this amount, and I like to always identify what each of the numbers are. So mass is equal to 14.63 grams, and then we have a volume measure right here. So this is my volume. So I know mass, I know volume, so I have density equals mass over volume, and I can just plug into my formula point here. I want to use my units because I'm going to end up with grams per milliliters. And when I plug this into my calculator, so this calculation equals 1.38 grams per milliliter would be the density. Let's do this next one. Standard bar of gold weighs 27.5 pounds. In kilograms, that's this amount. If the density of gold is this, so I know there's my density. I know this is my mass right there. And it says what volume. So I do not know volume, so I need to solve for volume. So I'm going to manipulate my equation to solve for volume, and I get volume is equal to mass over density. So let's plug in our mass. So we have 12.5 kilograms divided by 19.39 grams per cubic centimeter. And I want you to notice that we do not have the same unit. So our units are not going to cancel to give us a volume unit. So I have kilograms here and grams here. So you need to change one or the other, and I think it's easiest to change my kilograms. So if I change my kilograms to grams, I'm going to move my decimal over 3 places. So this would give me, let me just erase this here. All right, so this many grams. So for the volume, let's go ahead and put it into our calculator. And we get 644 cubic centimeters. Your cubic centimeters is in the denominator, and we divide, it becomes in the numerator. Okay, let's do one more. This is our last example. So aluminum has a density of, so I know my density. What would be the mass? So that's what I need to solve for. And I do have my volume. So my volume is right there. So again, density is mass, mountains over valleys. Whoops. And I want to manipulate it to solve for mass. So mass is equal to density times volume. I just multiply each side by volume. That's how I got that. And volume cancels. And so let me plug into this new formula. So we have 2.70 grams per cubic centimeter, and times by our volume, which is 55.0 centimeters. You can see centimeters are going to cancel to give you a gram as your mass unit, which is what we want. So in the calculator, 2.7 times 55, I get 148.5 grams for the mass of my aluminum. All right, so that concludes our scientific unit, and specifically working with density and doing some problems with density.